Hey, what's up, guys? So, back again at the Python Backend Stacked Playground, where we have been prototyping a lot of different things over the last year. Um, I still have to get into a little bit of the programming in Rust, which I want to get into, but just haven't had the time. And there's also AI generated mini lessons for Python and Rust. And I think we did about all the way up to day 30 of Python, and I want to start all the way over from scratch from Rust because something I just want to get into a little bit more is just becoming better at Rust. Usually, they say to pick two coding languages. Python is one; it's a really good scripting language, and then to pick another that's like a compiled language, so more for like systems programming. So Python is really nice for data science and scripting and prototyping. And then you want to use like a statically typed compiled language like Golang is a really good one. Java, if you're into Java. Rust is something really popular these days, or C++, something like that. Um, I think a lot of people, yeah, like getting into cybersecurity, all that kind of stuff. They say to pick two coding languages. So Python and Rust, I think, are pretty bulletproof ones to have on a resume. Um, so I've yet to get into these AI generated mini lessons too. Um, okay, so like we're on Vibe app 22 and a lot of things going on here as well. So like a lot of concepts going on. So like we are using Energy Plus, which I'll circle back to this as well. Um, so this is like the tool simulating the building physics and the fuel use of the building. So like for the school in southern Wisconsin, we have actual utility records, and then we have sub-metered electrical energy too. It's an all electric building, no natural gas. It's heat pumps, geothermal HVAC system. So heat pumps, it's a refrigeration cycle. Each classroom has a little unit above the ceiling where it can do heat or cool. And then it has a geothermal loop. Condenser water for the refrigeration cycle is pumped through the ground, and it's like very the most energy efficient probably um, HVAC system you have. But the problem we have with this building is a peak demand in the winter when everything starts up. So the building starts up, it's really cold, and that big surge of electrical energy to heat the building. Um, so that's what we're trying to reduce their energy, not reduce their energy, reduce their electrical demand. So that's units of power. Energy is units of kWh. So we're looking at kW, and then just a lofty goal. Maybe we can reduce it by 30%, 20%. And just some of the numbers that I was playing around with, that's like 4,000 bucks US just from their trying to reduce that peak demand. So it's also a charge that they get ratcheted into for their entire year, part of their rate tariff. So their utility bills that they pay, um, because they peaked that one time in the winter, that cold morning in January, um, they have to pay like not a fine, not a penalty, but it's just built into like a clause of their utility bill. Is like they're kind of locked into paying this high demand charge for the rest of the year, which is really common. Um, so we're kind of looking into if you reduce that peaking event, um, then it'll save on your utility bills for the rest of the year because you'll pay lower demand fees. Um, yeah, so we're kind of playing around with reinforcement learning to see if there's a way to for a reinforcement learning algorithm, which is a form of artificial intelligence. It's a branch of machine learning, to see if we can smooth out that demand. So we'll get into looking at more of the charts again in the next couple of days. I suppose I could we could kind of glance at it real quick if I can find it in a hurry. So just do some of the stuff might be kind of like redundant, but these are these heat pump units that every classroom has, degrees Fahrenheit, imperial units here. So this is just a building automation schematic. So this is like that refrigeration cycle in each one of these classrooms that has to make heat through a refrigeration cycle, which is actually a really efficient way of making. It's even in the right conditions, it's even higher efficiency than natural gas boiler. Um, and then this is part of the pumping system that pumps water through their geofield. This is in the middle of summer, so some of these numbers that they pull out of the well, 60-degree water that they get to make cooling with in the summer. So in the winter, I think it dips down into the 40s. So they pull all the heat out of the ground, and then in the summer they reject all the heat back into the ground. So um, this is like what we're modeling in EnergyPlus. Maybe we could just look at some of this data too. So there's just like a lot going on. And then we're going to look into reinforcement learning too, which is a whole other can of worms. But even from a mechanical perspective, this can be a lot to look at too. So this is, this thing keeps dying. I have to re-enable you. Oops, highlighter. So this is degrees Fahrenheit. So like gets up to 190s or so in the middle of summer, and then in the middle of winter, where we are, very hot upper Midwest, still gets really hot and humid in the summers, and it gets really cold in lots of snow, lots of frozen lakes in the winter too. So this is where we peaked right here, electrical usage on the coldest morning, minus 10 degrees Fahrenheit. And I wanted to just show you, so plant supply temp. So this is data that we could actually be inputting into EnergyPlus as well for calibrating the models. But I think that this is the ground loop temperature. So like, as you can see, just from here, like the building is shifting into, we're heating the building in this temperature range. And then we're cooling the building up here, and you can kind of see just in the condenser water temps, like they're putting this water back into the ground, 70 degrees or so. And then this must be right in the area, like when it starts pulling heat from the ground. So look at these temperatures. They're going all the way down into the 40s degrees Fahrenheit, which is really cold water to be making heat from. But the manufacturers design these units to do that. So especially here too, like this is where I think this is like mechanical engineering theory, like the equipment gets less efficient too, as this groundwater gets colder. That to make heat, it's just less efficient. So our power usage goes up again. So kind of cool. So like what I'm using AI agents to do is to calibrate an EnergyPlus model, kind of all based off of data pulled from the building automation system. And then the AI agents are iterating at calibrating the model to guideline 14. So like if you go look up ASHRAE guideline 14, this is like a measurement and verification guideline. So something that I think that's probably been around forever. It's nothing new. Really popular in like the ESCO industry, performance contracting. The person doing measurement and verification quite often has to put together some kind of math model, statistics model, and then ASHRAE has a criteria um, for the model should meet be a certain percentage from actual fuel use too, both on yearly consumption and then also there's a parameter for monthly consumptions too. So maybe we could just kind of browse at some of this data too. Let's just kind of look back. This is like some of the stuff on like what the average electric load profiles. So this is something I've been doing too with the EnergyPlus is like not only having AI agents I iterate, dialing in the physics model to the actual fuel use of the building or getting kind of close. It gets it kind of close. It's also, I'm having it match up the best of the abilities for peaking as well. Trying to think. So like I'm kind of cheating a little bit too in the EnergyPlus model is I'm lumping 5 or 6 zones of the building. I'm not specifically modeling every individual zone perfectly, partly because I don't have the good records of the building, and EnergyPlus does have an auto sizing of the HVAC system. So if you don't have good records of the building, it kind of gets into like HVAC designers kind of use like I don't have an HVAC design background, but some like really good HVAC designers like they just know energy code assumptions. They just know fan sizes by kind of bench ballparking, so that they kind of use some of that knowledge. And EnergyPlus has some features of auto sizing a zone of heat pumps. There could be 20 of them in that zone, so it models it like it's one big heat pump. And then so it's kind of it's kind of cheating, but it still meets the fuel use criteria, um, guideline 14, and this is a proof of concept too. So keep that in mind. It's not perfect. I just wanted to see if you can just kind of if the reinforcement learning can kind of do this, and if this was a production grade demand side management problem to solve, you could you do much better detailed analysis in EnergyPlus. There's some people that specialize just in EnergyPlus itself. I've seen some like really talented upper graduate engineering, they had master's degrees in engineering and they studied EnergyPlus in academia. I've also seen PhD students in mechanical engineering that have that, and they're know all about reinforcement learning. So there's like a whole bunch of people that study reinforcement learning and all this physics modeling in academia, which is really cool. Yeah, and then we're trying to prototype this, and how could the control system eventually design it so like the control you have to interact with the real physical system. So it's like a couple key players is like that mechanical engineering person, reinforcement learning person, and then there's like an IoT engineer, software engineer. So upper graduate mechanical engineering on EnergyPlus, upper graduate computer science person on reinforcement learning, and then the software engineer that specializes in the IoT edge and smart buildings. So a fair amount going on here. And then sometimes there's just a plain old energy engineer, which is usually just a mechanical engineer that is really good on energy audit calculations. So this is like what we're kind of up against. This is our peaking day. We peaked here. So this is a scatter plot of the data, which I think I showed. The middle, during mild weather, shoulder seasons, not a lot of electrical power consumption, which is typical if you want to see this nice V curve. Not even in the middle of summer to heat the building. So like these heat pumps, or I'm sorry, not in the middle of summer to cool the buildings, but to these heat pumps really draw a lot of electrical energy to heat the building, especially in those plots where I showed you when the well gets saturated in like the groundwater goes down into the 40s. It's probably really, really efficient in those first couple weeks that they have to um, heat the building, and then the groundwater is still hot. They can pull that heat out of there, but then soon they're sucking all of the heat out of the ground and losing some efficiency, I think. So this is that peak day, Monday morning. This um, orange line is the outside air temperature. Surprised I still have school. 7 degrees below Fahrenheit is pretty cold. And they peaked it right here. So like you can see that the HVAC system started at 3 o'clock in the morning probably. And then it must have got up to set point, and then kids probably start arriving around here, and then you start ramping up again with plug loads, and who knows what the building's doing then too. HVAC system starts responding. Other loads in the building, like electrical load or lighting loads, plug loads. There's a dedicated outside air HVAC unit too for ventilation, and that's where they peaked. So like the idea is that in theory, if you ran the building 24/7, um, and we maintained the building at temperature during these cold snaps that usually always last for at least 3 days in Wisconsin. Any cold place cold in the world, I'm sure, like 3-4 days. So like it's very common for people to run the HVAC system 24/7 in cold heating or cooling events. Peak July, humidity is really high, and you could probably do something similar too. So maybe if the idea would have been like if the this is what I want to see, like if the reinforcement learning can understand this, is and we should be able to model this too in EnergyPlus, that if the building was running 24/7 during this event, would the demand have stayed below 200 kW? Would they be paying for this, which is a big chunk of change. But you have to keep in mind too, like when you run the equipment 24/7, that you're going to pay a penalty for that too in kilowatt hours. So kW, and then there's also elapsed energy consumption of kilowatt hours. In the AI, yeah, we still have to get into reinforcement learning, reward policies, and all that stuff, because that's what really makes us run behind the scenes. So hopefully that makes sense. So like electrical power in kW, and then there's electrical energy. I think when I was first starting out, someone had the comparison that um, electrical kW, this would be like the speedometer on your car, and then kilowatt hours, the units of energy, that would be the odometer. That would be the elapsed miles or kilometers that you presented. So there's a price for uh, elapsed miles you travel, and then also that acceleration you pay. In the smart building here, you have to pay for both. Okay, so maybe we should. I did want to show you maybe a little bit about the guideline 14. So the the AI agents, so like they're iterating. This is stale too. This data's old because I'm coming up with these other problems too that the AI agents. Um, so I had to match up the guideline 14 for energy consumption, fuel use of the actual fuel use for the year. So that's one criteria. This is what this meets here too. Where after 80 iterations or so, like we got this model building that's kind of these lumped zones to meet guideline 14. And I had to push the heck out of the AI agents to try a whole bunch of different strategies. It's like, keep going. Like I would have them work for 10 iterations and then find something that works, change the wall to window ratios, change some of the occupant plug loads, like assumptions, um, optimal start algorithms. So like, and we kind of match it up over time. So like, these are the two Astro Guideline 14 requirements. And I think it's like this mean bias parameter, gate 5, the 5%. This is what um, requires your monthly records to meet as well. So I have to brush up on some of this. It's been a little while since I took a look at this. So this is kind of like what we do. It's like we model actual fuel usage to the physics simulation of EnergyPlus. Best model after 78 iterations. So I think you got the point. And then, so that is like step one out of the process of many. Okay, so let's get into the fun stuff. So now we can start looking into reinforcement learning as well. Keep on losing my little mouse guy. Okay, so hopefully that makes sense. So we just covered the bases of the mechanical engineer's specialty, the EnergyPlus, and then dialing in the fuel use, and then dialing in the architectural records for the building, which is a whole huge can of worms specialty in itself. And then doing it with AI agents is super experimental. And I'm really curious if there's a model context protocol server for EnergyPlus, there has to be quite a few other people doing this. So I just haven't really heard much about it. And then the next thing I want to chat about, which we chatted about on this other video too, is the last couple videos kind of driving this point home. It's like the building automation scheduling. So this will be kind of like what the AI agent gets to play around with. Is like we saw on the electrical load profiles, is the building that cold snap, the HVAC system started like right around 3 a.m. This is just what I showed yesterday. This is just the workbench tool for setting up building automation and the Tritium framework. And then this is just a generic building automation run calendar widget. And I think it's like a really good way of just kind of thinking like the AI agent through reinforcement learning. They get to play around with this, like sliding up these different schedules, and it can has the ability to adjust pre and post occupancy. So it has like a fixed, there'll always be like a fixed schedule for the building, and then usually optimal start algorithms start equipment beforehand to bring the building up to temperature. So yeah, so hopefully that makes sense. Is the AI agent will have the ability to start running equipment earlier, or even 24/7 if it has to. And it'll iterate on that best guideline 14 EnergyPlus model. It'll use this model to train the reinforcement learning algorithm over and over and over and over. So this is experimental to see if I can even get this to work. And like what we talked about before, it'll just do this once a day. If this was running in the real world, it would set the run schedule just once. So like if equipment needs to come on, and this here it'll set it once, and then the whole building will do its normal thing all day, and then it'll by midnight again it'll calculate, it'll gather the data, how it performed, recalculate its reward, and then readjust the model tuning. So it's just retuning itself once, not every time step, which I think has a lot of negative. When people talk about reinforcement learning and smart building applications, they say too much compute, too much compute. I've heard this from a lot of people. Just say maybe they're doing something at every time step. Maybe uh, there are applications where they're optimizing a chiller plant or something like that. So they are making a decision at every 5 minutes or something, which is probably a ton of compute to do that. But this is just once, and then it can, if it takes a whole day to retrain that model, that's fine. So, in my opinion, I think when you don't have to have a model adjusted, retuned every time step, you can have a cheaper computer. That's where I'm going with that. Okay, so I think like that point is driven home. Yesterday we prototyped the BACnet script with Python, Open Weather Map API that will, the idea again would be to gather weather data at midnight, and then it would also scrape the what's the building temperatures at, what day of the week is it, and the AI agent will kind of make an assessment from there. Okay, so let's get into reinforcement learning just for a little bit, and then we can play around with this more this week, I guess. So, just to state, I don't have a master's degree in computer science, and I have not studied in depth the different algorithms under the hood. But I have followed over the course, 5 years plus, played around some tutorials, that kind of stuff. This was probably really popular. Rewind, not quite 10 years ago, I bet 2018. Um, this open AI, I think, ChatGPT, the makers of ChatGPT, I think they're the ones that came out with this concept for gymnasium is like where reinforcement learning, it's a framework basically that they use to train reinforcement learning algorithms, and then it's stuck around for probably the last 10 years, I bet, and it's here to stay, I guess. So and I and there's not much to it actually. So like what there's just a lot that gets baked behind the scenes. So basically like observation. So basically like what we'd be doing in the real world is pulling zone temps. We'd be pulling a building automation schedule data, day of the week, and then it's stuffed into like an action space. And then this is like where it kind of does its thing. It would set the schedule for the day, even calculate the reward when it's done. Um, so we'll get into this more. It's a gym, a reinforcement learning gym for Python world, basically how to train reinforcement learning agents. Um, and then I want to use this Stable Baselines 3 project. So this is a very active project that's been around for a good number of years too. Um, and I think like for a while that Python was kind of getting really popular in data science. Rewind 5 years or so before this whole generative AI craze. Deep learning was popular, and Python was like the go-to popular thing for neural networks and machine learning, etc. And but there was nothing. There was no packages for reinforcement learning until Stable Baselines came out, and Stable Baselines, I guess, is up to number 3, which is really cool for a person like me that doesn't have that master's degree in computer science. Is like now there is a Python package where you can just change a couple lines of code, and voila, you're changing something very radical under the hood. It would be like if you could drive a car, you could change it into a jet engine from a combustion engine. Like the level of differences going on behind the scenes under the hood is kind of like what stable baselines does. So like if we just like look a little bit at the documentation here, um, I want to play around with this the next couple days. Um, so yeah, tons of stuff like which algorithm should I use? All these algorithms have like different properties, and um, at least when I was using generative AI to make the code, it already kind of knows I should be marching down the path of deep Q learning and this policy approximation algorithm. But there's a whole bunch of other ones too. And I think that there's other ones that aren't even listed. Like this is like model free. Uh, so let's look at carpol. So you can see like stable baselines is already built on the gym environment. And just like it's basically just like this, like from Python, just from stable baselines 3, import a new algorithm, and you just yeah, you just change around like literally like just a couple lines of code, and a person like me can do reinforcement learning now, which is really cool. It's awesome for prototyping. Um, yeah, video series on YouTube, which maybe we'll kind of look into that too. Um, so yeah, so what I've been doing this whole week is like just seeing if AI agents can iterate on finding problems in the EnergyPlus. So yeah, so back up a second too, like we are using EnergyPlus. Where there's quite a few different reinforcement learning libraries out there too for EnergyPlus. IBM even has something out there too, um, which is kind of wild. It's been around for, looks like it's been updated for a while, but we're using Antoine's um, most recent thing. This guy right here. I think Antoine has a degree in master's degree in computer science, so he probably knows really well what goes on behind the scenes. So, these ideas are there. Um, they've been around for years and years, actually, to use reinforcement learning with physics simulation, like EnergyPlus. So, why not use generative AI to help us prototype? So we're using generative AI to build the code bases to help us prototype. Okay, so let's just spend like a couple minutes at um, playing around with the gym environment. So I just have this little, I just whipped up some code bases, or like some small code base here, which is, I want to play around with, there is this an environment called cart bowl, where the AI agent has to balance a stick or else it falls over. And there's one called the lunar lander too. Um, and I just vibe coded um, little environment. This would have taken me probably years to make if rewind a couple of years ago. So let's see if this works. Let's see if we can play cart pull as a human. So I'm just gonna try my keyboard here. Oop, I failed. Try that again. I don't even know if it even did anything. Looks like it failed already. So like if we try lunar lander, this is the little lunar lander one. Should have made this a little bit bigger. Um, ooh, see, like this is like a little game. Um, try that again. Oof, crash the lunar lander. So the lunar lander has to get between those two flags. And then not like it's a real little moon lander thing, and there's some fake physics in there for rocket thrusters or gravity, and it's a really famous AI agent reinforcement learning playground with Jim. So I'm just going through this stuff really fast. Like what we can do here is, which we'll get into a little bit more. So if we train, let's just see if like this one, and I think we'll just stop this video here for the day. Okay, so this is using, we're going to train cartpole. Let's see what we got, the cartpole environment. So, and like what this script is doing is it's every 5,000 trains. So the computer played it 5,000 times by the time that first thing popped up. Oop, another 5,000 times. And wow, it's already figured out how to balance the pole way better than I have. Oop, it looks like it tipped over. Let's try another 5,000 crap. And it's literally that fast. So these are like really famous, documented reinforcement learning. Been around for years and years, and there's like some metrics that we need to get into a little bit more. Learning rate, policy gradient loss. So basically the point is like what I'm hoping to do with EnergyPlus is to compare deep Q learning to PPO and kind of do something like similar as like and try and figure out like what is the best algorithm here. A lot different than balancing a pole. We're going to be scheduling HVAC. And unfortunately, there really is not a cool GUI. Maybe it'd be really cool to vibe code something similar where every, so I don't even know how many, it looks like these agents do pretty darn good after 5,000 tries. It's way faster than a human can balance a pole. And I'm trying to figure out like what is that magic number with EnergyPlus, if it can even figure it out. So like, yeah, very experimental. Can the AI agent figure out how to lower those demand charges in the building? And then the idea would be like what we're doing here is like we're which I think tons of people have already done with EnergyPlus and reinforcement learning, very popular. Lots of stuff has been around about using EnergyPlus and reinforcement learning. Is the AI agent, can it figure out from a cost perspective how to optimize the building schedules? So that's where we're going. Pretty experimental, and yeah, so okay, so here we can even do, let's just do one replay after, let's just do one replay of the game. So like basically what it's doing is it's all Python code, and then these are runs. So these are models. So this is like up.pkl. If you guys can see that, that's like that's a pickle, a serialized model. So like what we would be doing is in EnergyPlus world is if this works, we'd be serializing a model and then you know bringing it to the real world and see if it works. So just like if you're following this, this job won't be bringing it to the real world. But for one thing, this automated logic system with the heat pumps is not even BACnet, I'm pretty sure. In the client, I don't think I'll be able to talk them into this, but I can get the data to prototype it. But if you wanted to, I am open for work. So looking for people to play around with this kind of stuff, and let's kind of have some fun. Let's learn a little bit about reinforcement learning, and yeah, I think like with this whole era of vibe coding, we can prototype this stuff for like really cheap. So I'm doing for a $20 a month. Actually, I think I'm doing $60 a month, and I have to bump it up to the next tier here. Cursor. You can do. Oh, it's you. We can make these things so cheap. And when things are cheap, it's more attractive to put it in buildings, and it's a win-win situation, in my opinion, on making clients happy and drumming up business. So hopefully you guys are liking this. This is still really experimental, and um, I'm really excited about this kind of work. It's this would be this would be really really cool to do full time, all day, every day. Oh, and I think like the next can of worms too that some people have reached out to me too is like, can you get into time of use pricing? So like, um, it's a lot of so like uh, so this simple school they just have like one on peak rate, one off peak rate, and then one demand charge. So it's like calculating the price. The economics is really easy. And then where these projects are really popular is what if the pricing changes per hour, like California or Ontario, I think Australia, and probably lots of other places. Um, the electrical energy changes per hour, and like how do you factor this in now? So now we're throwing more complexities at the problem. So I'm kind of playing around with reinforcement learning, and there might even be I have like this grid search idea too. So like we can play around with reinforcement learning and then kind of look at this brute force algorithm that's kind of a smart brute force way to seeing if it can find an optimized solution as well. So a couple cool things going on. Hopefully we can study this topic for a while, and hopefully you're liking this. Ping me on Discord or LinkedIn if you're enjoying this series. Talk to you later.